In this video, we're talking about Boolean expressions. We're going to review how to use relational operators and Boolean operators to build expressions that can help us make decisions in our program. Boolean expressions are the first tool that will allow us to change the flow of control of a program. The flow of control means the order in which various statements in your program are executed. By default, the flow of control is always sequential, which means that the computer will start reading your main method at the top and work its way one instruction at a time towards the bottom. And those instructions primarily go in order. But there are two types of statements that can create a non-sequential flow of control. The first one are if statements or decision statements, and the second are loops. We're going to learn about conditional statements and also loops in the next few weeks. Both conditional statements and repetition statements use Boolean expressions to determine how the flow of control should continue. They're used to make decisions in the program to either do an instruction or skip it, or to decide between multiple alternatives, or to decide whether or not to repeat an instruction before continuing on with additional instructions in the program. Today, we're going to do a quick review of Boolean expressions before we think about how to incorporate them into conditional statements and repetition statements. Boolean expressions are ways of capturing logic in our program, and sometimes they're called logical expressions for that reason. Boolean expressions are always a combination of variables, other expressions like arithmetic expressions, relational operators, and logical operators. You probably remember these components from previous programming experiences. For example, relational operators allow you to determine the relationship between two values. These can either be making comparisons between two numeric values or making comparisons between two string values. The relational operators for primitives are less than or equal to, greater than or equal to, not equal to, which is an exclamation point followed by an equal sign, and the equality test, which is two equal signs next to each other. Those operations allow us to compare two data values on either side of the operator and determine their relationship to each other. If we're doing relational operations on string data, we need to use other operations. We need to use the built-in methods compare to and equals. And you probably remember those from the previous video lecture on strings. Let's do some quick examples of relational operators. So suppose that in our program, we have an integer variable called value, and it stores the number 10. Suppose we want to check to see if the value is less than 10. We could type in value less than 10. That would create a true result if the contents of value are less than 10 and false otherwise. What do you think the answer would be in this case? It would be false because 10 is not less than 10. Right now, the variable value is storing the number 10, which means that this expression, this comparison, would be false. What if we said, is value equal to 10? Now the variable result would store true, and that's because the contents of our variable called value is equal to 10, so our equality test will return the value true. Suppose that we wanted to compare a string value to another. Suppose we have a string value called greeting, and we want to find out how is that value equal to hi. We could say, is greeting dot equals hi. So now we're going to check to see whether the contents of our string called greeting are equal to the characters hi as a string. What do you think the result will be? In this case, it's going to give a false answer. That's because our greeting stores hello, and that's not the same characters as in our string literal hi. We could, of course, edit that. If we were checking to see if the string called greeting stores the same characters as the string literal hello, then we would get a true answer. Those two values are equal. So relational operators, those can be one component of a Boolean expression. Boolean expressions can also have other types of expressions in them. For example, maybe we want to check to see whether value is equal to 10 plus some other number. We could modify our instruction to see whether value is the same as 10 plus value 2. Of course, in this case, that's going to be false. 10 plus 5 is 15, and that's not the same as value, which stores the 10. But the point is, you can use an arithmetic expression in either side of the relational operators. When we're building Boolean expressions, we can also use logical operators to combine together multiple ideas. And there are 3 logical operators. They're and, or, and not. And Java uses kind of interesting syntax for representing those. Instead of typing out the word and like we did in Python, you're going to type in 2 ampersand signs next to each other. Instead of typing in the word or, you'll type in 2 bars next to each other. And that key is probably something you're not used to typing. On my keyboard, it's right above the enter key on the right side of the keyboard. And then finally, the not operator is the exclamation point. That's pretty standard. We could use that in Python in addition to being able to use the word not. Mathematicians have created rules for how to combine together ideas using these 3 logical operators. And it's important to just memorize these rules. Perhaps they're intuitive to you because they are the same as rules that we use in everyday life when we're speaking and using words like and, or, and not. Big picture, if we have 2 values and we're combining them together with an and operation, the result is true only if both sides of the and operator are true. So if P is true and Q is true, then P and Q are true. If either or both of them is false, then the answer is false. For example, if I asked you whether you like Marvel movies and you have tickets to see a Marvel movie this weekend, you would only answer true if both of those things were true. If you like Marvel movies and you have tickets to see one this weekend, then you would say yes. If you like Marvel movies, but you don't have tickets to see one this weekend, you'd say no. If you don't like Marvel movies, but you're seeing a different movie this weekend, you'd still say no. And if you don't like Marvel movies and you don't have tickets to see one this weekend, you would say no. So the and operator, again, results in a true evaluation only if both of the operands are true. Both of the expressions that it's combining together have true values on their own. When we combine together expressions using the or operator, the result's true if either or both of them are true. So if I asked you if you like Marvel movies or have tickets to see a Marvel movie this weekend, you'd respond true if both of those things were true. You'd also respond true if you just like Marvel movies but don't have tickets this weekend. And you'd respond true if you have tickets to see a Marvel movie this weekend, but you don't actually like Marvel movies, you'd still say true. And it's only if you didn't like them and you don't have tickets that you would say false. Finally, the not operator allows you to take the inverse of a particular value. So it's like asking, is this not true? So it's like saying, is it not true that you like Marvel movies? And so I would answer, that's true if I don't like Marvel movies. But if I do like Marvel movies, then I'd say false, taking the inverse of the actual value that I'm evaluating. Let's practice evaluating some Boolean expressions. I'm creating a small example where I have 2 variables, x and y, that store some integer values, and I have a Boolean variable called result where I can store the result of a Boolean expression. I'm going to store the value 4 in x and the value 6 in y. I'm also going to make a variable called name that stores CPSC 220. Let's do the first problem together. Anytime I'm attacking one of these problems, the first thing I do is fill in the data values from memory. And so I'm going to retrieve the value of x from memory, that's the 4. And then I'm going to retrieve the value of y from memory, that's the 6. And now I'm going to start applying the various operators in my expression. So I'm going to do the part inside the parentheses first. Inside the parentheses, the first part I have to do is the plus sign operator that has precedence over the relational operator. So I'm going to add 4 and 2 and get 6, and then just copy over the rest of my statement. Now I still have an expression inside the parentheses, so I have to tackle that next. I'm going to check to see, is 6 less than 6? That is false, because those 2 values are equal. 6 is not less than 6. And now finally, I'm going to apply my logical operator, the not operation, to the false value. And remember, that just takes the inverse of the value. So my final result for the expression is going to be true. At this point, you should pause the video and try to work out the remaining questions on your own, then unpause the video to check your answers. Again, I approach all of these questions the same way. The first thing I do is type in the values from the memory cells. And I start with the highest order of precedence first. In this case, it is the information inside of the parentheses. So I'm going to check to see, is 4 not equal to 6? That is true. 4 is not equal to 6. Now I'm going to evaluate the expression in the other side of the parentheses. I'm going to check to see, is 6 equal to 5? And that's false. So my first step expression is x not equal to y. That's going to evaluate to true. My second expression over here on the other side of the and operator, that's going to evaluate to false. When I combine together a true and a false with an and operator, I'm always going to get a false answer. Remember that the and operator only gives a true response when both of its operands are true. Let's do the next one. This one has an or value in it. Again, my first step is always copying over the values from memory. In this case, it's 4 is not equal to 6, or 6 is the same as 4 plus 1. So again, I'm going to start evaluating inside the parentheses. First, I check to see, is 4 not equal to 6? That is true. And then I'm going to combine that together by checking to see, is 6 the same as 5? I'm going to get a true. 4. And then is 6 equal to 5? No, that's false. So now I need to combine together the true value and the false value using an or operation. Remember, the or operator returns true if either or both operands are true. So because we have at least one true operand, the full result will be true. I use the same approach whenever I am evaluating information with a string. So here I want to check to see whether the string CPSC 220 equals the string CPSC 110. And you folks are super smart. You can see looking at them that no, those are not the same. So the answer is going to be false. And then finally, remember that Java includes a special operator that allows us to do less than or equal to, greater than or equal to, and not equal to, all in one method. And that method's called compare to. In this example, we are comparing CPSC 220 compared to the string, literal, CPSC 220. We can see that those two strings are the same. When the strings are the same, the compare to method returns a value of 0. And then we're checking to see, is that result greater than 0? So again, when we compare our two strings, CPSC 220 and CPSC 220, the contents of those two strings are the same. So we're going to get a 0 as the result from the compare to method call. And then we're checking to see, is that greater than or equal to 0? Yes. 0 is greater than or equal to 0. So our final answer here is going to be true. It's important to do some practice where you use abstract expressions like these to test your knowledge and understanding of both order of operations and also how various expressions can be combined together using logical operators, because that really ensures that you understand how the computer is going to evaluate Boolean expressions. And you can't build Boolean expressions to use in conditional statements or loops in your program if you don't understand how the computer thinks about the data values and how it interprets the various operations at a fundamental level.